Welcome to today's video. If you're preparing for the IELTS exam, having a strong vocabulary is crucial, especially when discussing important topics like pollution and the environment. In this video, I'll be introducing you to 101 advanced IELTS words that will help you speak and write more effectively on these crucial issues. From air pollution-related words to ocean pollution vocabulary, we'll cover it all. You'll also learn the meanings of these terms and how to use them in context. So, let's dive in and boost your environmental vocabulary for a higher IELTS band score.
Incinerator. A device for burning waste material at high temperatures. Furnace. Cremator. Burner. Incendiary. Why are incinerators considered an effective waste management tool? Incinerators, or furnaces, are highly efficient for reducing waste volume. Cremators can handle medical waste effectively, while burners and incendiaries are used to dispose of hazardous materials. Biohazard. A biological substance that poses a threat to human health. Hazardous material. Infectious agent. Contaminant. Pathogen. What are the potential risks associated with biohazards in a laboratory setting? Biohazards, or hazardous materials, can include infectious agents, contaminants, and pathogens, which all pose significant health risks in a laboratory environment. Sludge. Thick, soft, wet mud or a similar viscous mixture. Muck. Ooze. Mire. Sediment. How does industrial sludge impact the environment? Industrial sludge, or muck, often contaminates water sources. Ooze and mire can settle in rivers, and sediment buildup can harm aquatic life. Sewage. Wastewater and excrement conveyed in sewers. Wastewater. Effluent. Drainage. Waste matter. What are the challenges in managing urban sewage systems? Managing urban sewage involves treating wastewater and effluent properly. Drainage systems need to handle large volumes of waste matter effectively to prevent contamination. Effluent. Liquid waste or sewage discharged into a river or the sea. Discharge. Outflow. Wastewater. Pollution. What measures can be taken to reduce the negative impacts of industrial effluent? Reducing industrial effluent, or discharge, involves treating outflow and wastewater before it reaches natural water bodies, thus minimizing pollution. Soot. A black powdery or flaky substance produced by incomplete burning. Ash. Smoke. Carbon. Residue. How does soot contribute to air pollution, and what can be done to mitigate its effects? Soot, or ash, from industrial smoke can significantly contribute to air pollution. Measures to reduce carbon emissions and managing residue can help mitigate these effects. Detritus. Waste or debris of any kind. Debris. Rubbish. Waste. Litter. What are the environmental impacts of detritus in urban areas? Detritus, or debris, often clogs waterways. Rubbish and waste buildup can lead to pollution, while litter is harmful to both wildlife and human health. Aerosol. A suspension of fine solid particles or liquid droplets in air or another gas. Spray. Mist. Vapor. Fog. How do aerosols impact the environment? Aerosols, or sprays, significantly affect air quality. Mists can contribute to respiratory problems, while vapor and fog can lead to visibility issues and health concerns. Particulate. Microscopic solid or liquid matter suspended in the air. Particle. Dust. Speck. Fragment. What are the sources of particulate matter in urban areas? Particulates, or particles, originate from vehicle emissions. Dust from construction sites, specks from industrial activities, and fragments from various urban processes contribute to pollution. Catalytic converter. A device for reducing pollutants in exhaust gases. Emission control device. Exhaust cleaner. Pollution reducer. Emission purifier. Why are catalytic converters important in vehicles? Catalytic converters, or emission control devices, reduce pollutants. Exhaust cleaners help lower harmful emissions, making pollution reducers and emission purifiers essential for cleaner air. Fallout. Radioactive particles that fall to the ground after a nuclear explosion. Residue. Debris. Fallout particles. Nuclear ash. What are the environmental impacts of nuclear fallout? Nuclear fallout, or residue, contaminates the environment. Debris from explosions can spread far, with fallout particles and nuclear ash posing long-term health and ecological risks. HAZMAT suit. A protective suit designed to shield the wearer from hazardous materials. Protective gear. Safety suit. Containment suit. Hazard gear. What are the key features of a hazmat suit? Hazmat suits, or protective gear, offer crucial protection. Safety suits are used in hazardous environments, and containment suits with hazard gear prevent exposure to dangerous substances. Polyethylene terephthalate. A type of plastic used in packaging and fabric. PET. Synthetic resin. Thermoplastic. Polyester. Why is polyethylene terephthalate widely used in the packaging industry? Polyethylene terephthalate, or PET, is popular due to its durability. Synthetic resins make it ideal for various uses, and thermoplastics and polyesters are key in manufacturing robust packaging materials. Unleaded. Fuel that does not contain lead. Lead-free. Clean fuel. Green fuel. Eco-friendly fuel. What are the benefits of using unleaded fuel? Unleaded fuel, or lead-free, reduces pollution. Clean fuels are better for engines, while green and eco-friendly fuels contribute to a healthier environment by minimizing harmful emissions. Asbestos. A heat-resistant fibrous silicate mineral. Insulation material. Fibrous mineral. Heat-resistant fiber. Fireproof material. Why is asbestos hazardous to health? Asbestos, an insulation material, poses severe health risks. Fibrous minerals, like asbestos, can cause lung diseases, while heat-resistant fibers and fireproof materials need careful handling to prevent harm. Contaminant. A substance that makes something impure or unsuitable. Pollutant. Impurity. Adulterant. Toxin. How do contaminants affect drinking water quality? Contaminants, or pollutants, degrade water quality. Impurities and adulterants can pose health risks, while toxins from industrial activities further contaminate drinking water sources. Remediation. The action of remedying something, especially reversing environmental damage. Rectification. Correction. Rectifying measure. Restoration. What steps are involved in the remediation of polluted sites? Remediation, or rectification, involves several steps. Correction of the contamination, implementing rectifying measures, and ongoing restoration efforts are essential for effective environmental cleanup. Decontamination. The process of removing or neutralizing contaminants. Purification. Disinfection. Sterilization. Sanitation. How is decontamination carried out in a laboratory setting? Decontamination, or purification, is crucial in labs. Disinfection processes remove harmful agents, while sterilization and sanitation ensure a safe environment for scientific research. Toxicity. The quality of being toxic or poisonous. Poisonousness. Lethality. Harmfulness. Toxicity levels. How can the toxicity of a chemical be determined? Toxicity, or poisonousness, is assessed through tests. Lethality rates, harmfulness evaluations, and measuring toxicity levels help determine the dangers posed by a chemical. Hazardous waste. Waste material that can pose a threat to human health or the environment. Dangerous waste. Toxic waste. Perilous waste. Risky waste. What are the challenges in managing hazardous waste? Hazardous waste, or dangerous waste, requires careful handling. Toxic waste disposal is complex, perilous waste storage must be secure, and managing risky waste involves strict regulations to prevent harm. Filtration. The action or process of filtering something. Screening. Sieving. Straining. Purification. How does filtration improve air and water quality? Filtration, or screening, removes contaminants. Sieving and straining are effective in purifying air and water, ensuring cleaner and safer environments. Wastewater. Water that has been used and contains waste products. Sewage. Effluent. Dirty water. Polluted water. What are the common methods for treating wastewater? Wastewater, or sewage, is treated using various methods. Effluent treatment, cleaning dirty water, and purifying polluted water are essential processes to protect the environment and public health. Bioremediation. The use of living organisms to remove contaminants from the environment. Biological treatment. Biocleanup. Biorestoration. Microbial remediation. What role does bioremediation play in environmental cleanup? Bioremediation, or biological treatment, involves using organisms for cleanup. Biocleanup techniques, biorestoration processes, and microbial remediation are effective in reducing environmental pollutants. Emissions. The production and discharge of something, especially gas or radiation. Discharges. Exhalations. Radiations. Emanations. How do vehicle emissions impact urban air quality? Emissions, or discharges, from vehicles degrade air quality. Exhalations of pollutants, radiations from engines, and various emanations contribute significantly to urban pollution. Decay. The process of rotting or decomposing. Decomposition. Rot. Deterioration. Putrefaction. How does decay affect the environment? Decay, or decomposition, plays a crucial role in nutrient cycling. Rotting organic matter, deterioration of materials, and putrefaction contribute to soil fertility and ecosystem health. Analyte. A substance whose chemical constituents are being identified and measured. Substance. Component. Element. Sample. What methods are used to analyze an analyte in a laboratory? Analytes, or substances, are analyzed using various methods. Components of the sample are studied to identify elements, ensuring accurate chemical analysis. Phytoremediation. The use of plants to remove contaminants from the environment. Bioremediation. Plant remediation. Green remediation. Botanical cleanup. What are the benefits of phytoremediation in managing environmental pollution? Phytoremediation, or bioremediation, involves using plants for cleanup. Plant remediation techniques offer green remediation solutions, making botanical cleanup an eco-friendly option. Volatile organic compounds, VOCs. Organic chemicals that have a high vapor pressure at room temperature. Organic pollutants. Airborne chemicals. Evaporative emissions. Volatile pollutants. What are the sources and effects of volatile organic compounds, VOCs, in urban areas? VOCs, or organic pollutants, are emitted by vehicles and industrial processes. Airborne chemicals contribute to smog, evaporative emissions affect air quality, and volatile pollutants can harm human health. Sanitation. Measures for maintaining cleanliness and preventing disease. Hygiene. Cleanliness. Public health. Sanitary measures. Why is sanitation crucial in densely populated urban areas? Sanitation, or hygiene, is vital to prevent disease. Maintaining cleanliness and public health through sanitary measures helps control the spread of infections in urban environments. Incineration. The process of burning waste material. Burning. Combustion. Cremation. Waste disposal. How does incineration contribute to waste management? Incineration, or burning, reduces waste volume significantly. Combustion processes, such as cremation of hazardous materials, offer effective waste disposal solutions, helping manage landfill space. Biodegradable. Capable of being decomposed by bacteria or other living organisms. Compostable. Degradable. Eco-friendly. Organic. What are the advantages of using biodegradable materials? Biodegradable, or compostable, materials break down naturally. Degradable products reduce landfill waste, eco-friendly options promote sustainability, and organic materials are safer for the environment. Toxicology. The branch of science concerned with the nature, effects, and detection of poisons. Poison science. Toxic substance study. Harm analysis. Risk assessment. How does toxicology help in understanding environmental health risks? Toxicology, or poison science, studies the effects of toxic substances. Analyzing harmful compounds and conducting risk assessments are crucial for understanding and mitigating environmental health risks. Anthropogenic. Originating in human activity. Human-caused. Man-made. Human-induced. Human-originated. What are the impacts of anthropogenic activities on climate change? Anthropogenic, or human-caused, activities significantly contribute to climate change. Man-made emissions, human-induced deforestation, and other human-originated actions alter the planet's natural balance. Pollutant. A substance that pollutes something, especially water, or the atmosphere. Contaminant. Toxin. Impurity. Waste. What measures can be taken to reduce pollutants in urban areas? Pollutants, or contaminants, must be controlled. Reducing toxins and impurities in the air and water, and managing waste effectively are crucial steps to improve urban environmental health. Greenhouse gas. A gas that contributes to the greenhouse effect by absorbing infrared radiation. Carbon dioxide, methane, nitrous oxide, fluorinated gases. How do greenhouse gases contribute to global warming? Greenhouse gases, like carbon dioxide and methane, trap heat in the atmosphere. Nitrous oxide and fluorinated gases further exacerbate the greenhouse effect, leading to global warming and climate change. Carcinogenic. Having the potential to cause cancer. Cancer-causing. Oncogenic. Tumorigenic. Malignant. What are the risks associated with carcinogenic substances in the environment? Carcinogenic, or cancer-causing, substances pose serious health risks. Oncogenic chemicals, tumorigenic compounds, and malignant agents in the environment require strict regulation to protect public health. Ecotoxicology. The study of toxic effects on biological organisms, especially at the population, community, and ecosystem level. Environmental toxicology. Ecotoxicology. Ecological toxicology. Bioenvironmental study. What role does ecotoxicology play in protecting wildlife? Ecotoxicology, or environmental toxicology, assesses the impact of pollutants on ecosystems. Ecotoxicology studies how contaminants affect wildlife, while ecological toxicology and bioenvironmental studies are essential for conservation. Mitigation. The action of reducing the severity, seriousness, or painfulness of something. Reduction. Alleviation. Moderation. Minimization. What are some effective strategies for climate change mitigation? Mitigation, or reduction, involves various strategies. Alleviation of impacts, moderation of greenhouse gas emissions, and minimization of deforestation are key methods to combat climate change effectively. Biodegradation. The breakdown of organic matter by microorganisms. Decomposition. Biological decay. Natural breakdown. Organic decay. How does biodegradation benefit the environment? Biodegradation, or decomposition, helps in waste management. Biological decay aids in recycling nutrients, while natural breakdown and organic decay reduce landfill waste, promoting a healthier ecosystem. Effluent treatment. The process of cleaning wastewater before it is released into the environment. Wastewater treatment. Sewage treatment. Waste treatment. Effluent purification. What are the methods used in effluent treatment? Effluent treatment, or wastewater treatment, involves multiple stages. Sewage treatment and waste treatment methods ensure effluent purification, making the water safe for release into natural water bodies. Fossil fuels. Natural fuels formed from the remains of living organisms. Coal, oil, natural gas, petroleum. What are the environmental impacts of relying on fossil fuels? Fossil fuels, such as coal and oil, contribute to pollution. Natural gas and petroleum emissions increase greenhouse gases, leading to climate change and environmental degradation. Carbon emissions. The release of carbon dioxide into the atmosphere. CO2 emissions. Greenhouse gas emissions. Carbon dioxide release. CO2 release. How can countries reduce carbon emissions? Reducing carbon emissions, or CO2 emissions, involves cutting greenhouse gas emissions. Limiting carbon dioxide release and CO2 release through renewable energy sources helps mitigate global warming. Industrial effluent. Wastewater discharged from industrial activities. Industrial discharge. Factory waste. Industrial sewage. Industrial outflow. What are the challenges in managing industrial effluent? Industrial effluent, or industrial discharge, requires strict regulations. Factory waste and industrial sewage must be treated effectively to control industrial outflow and minimize environmental harm. Nitrogen oxides. Gaseous compounds of nitrogen and oxygen. NOx. Nitrous oxides. Nitric oxides. N2O. What are the sources and effects of nitrogen oxides? Nitrogen oxides, or NOx, are emitted from vehicle exhausts. Nitrous oxides from industrial processes, nitric oxides from power plants, and N2O from agricultural activities contribute to air pollution and respiratory issues. Carbon footprint. The amount of carbon dioxide emissions for which an individual or organization is responsible. Environmental impact. Carbon emissions. Greenhouse gas emissions. CO2 footprint. How can individuals reduce their carbon footprint? Reducing your carbon footprint involves lowering your environmental impact. Cutting carbon emissions and greenhouse gas emissions, and minimizing your CO2 footprint through sustainable practices are crucial steps. Sulfur dioxide. A toxic gas released by volcanic activity and industrial processes. SO2. Sulfurous acid. Sulfurous anhydride. Sulfur oxide. What are the environmental effects of sulfur dioxide? Sulfur dioxide, or SO2, contributes to acid rain. Sulfurous acid formation, sulfurous anhydride emissions, and sulfur oxide pollution harm ecosystems, leading to soil and water acidification. Particulate matter. Microscopic solid or liquid matter suspended in the air. Particles. PM. Aerosols. Dust. How does particulate matter affect urban air quality? Particulate matter, or particles, degrade air quality. PM from vehicle exhausts, aerosols from industrial activities, and dust from construction sites contribute to respiratory problems and pollution. Smog. Fog combined with smoke and other atmospheric pollutants. Haze. Pollution. Smoke. Air contaminants. How does smog impact public health in cities? Smog, or haze, contains various pollutants. Pollution from industrial activities, smoke from vehicle emissions, and air contaminants worsen respiratory conditions and overall public health in urban areas. Emission control. The reduction of pollutants released into the air. Pollution control. Emission reduction. Air quality management. Pollutant regulation. What technologies are used in emission control? Emission control, or pollution control, employs advanced technologies. Emission reduction strategies and air quality management systems are crucial for pollutant regulation, helping reduce environmental impact. Waste management. The process of handling and disposal of waste. Waste disposal. Trash management. Rubbish handling. Garbage control. What are the key components of effective waste management? Waste management, or waste disposal, involves several components. Trash management, rubbish handling, and garbage control ensure that waste is processed and disposed of in an environmentally responsible manner. Soil contamination. The presence of hazardous substances in soil. Soil pollution. Land contamination. Soil degradation. Earth pollution. What are the sources and effects of soil contamination? Soil contamination, or soil pollution, results from industrial waste. Land contamination affects agriculture, soil degradation reduces fertility, and earth pollution poses risks to health and ecosystems. Groundwater pollution. Contamination of underground water sources. Groundwater contamination. Aquifer pollution. Water table contamination. Subsurface pollution. How can groundwater pollution be prevented? Preventing groundwater pollution involves controlling groundwater contamination. Reducing aquifer pollution and water table contamination and mitigating subsurface pollution are essential to protect water resources. Plastic pollution. Accumulation of plastic objects and particles in the environment. Plastic waste. Plastic debris. Plastic trash. Plastic litter. What are the environmental impacts of plastic pollution? Plastic pollution, or plastic waste, significantly harms marine life. Plastic debris clogs waterways, plastic trash contaminates ecosystems, and plastic litter endangers wildlife. Airborne toxins. Harmful substances carried in the air. Airborne pollutants. Airborne chemicals. Airborne contaminants. Airborne hazards. How do airborne toxins affect human health? Airborne toxins, or airborne pollutants, can cause respiratory issues. Airborne chemicals, contaminants, and hazards lead to serious health problems, including asthma and other respiratory diseases. Water purification. The process of removing undesirable chemicals and contaminants from water. Water treatment. Water filtration. Water cleaning. Water sanitization. What are the methods used in water purification? Water purification, or water treatment, involves various methods. Water filtration and cleaning processes, along with water sanitization techniques, ensure safe drinking water. Ozone depletion. The reduction of the ozone layer in the Earth's stratosphere. Ozone layer thinning. Ozone reduction. Ozone layer loss. Ozone decline. What are the causes and consequences of ozone depletion? Ozone depletion, or ozone layer thinning, is caused by CFCs. Ozone reduction leads to higher UV radiation, ozone layer loss impacts human health, and ozone decline affects the environment. Hazardous materials. Substances that pose a risk to health, property, or the environment. Dangerous materials. Hazardous substances. Hazardous chemicals. Risky materials. How should hazardous materials be handled to ensure safety? Hazardous materials, or dangerous materials, require careful handling. Hazardous substances and chemicals, along with other risky materials, must be managed with strict safety protocols to prevent accidents. Urban runoff. Water from city streets and drainage systems that carries pollutants. Stormwater runoff. Urban stormwater. City runoff. Urban drainage. What are the environmental effects of urban runoff? Urban runoff, or stormwater runoff, carries pollutants to water bodies. Urban stormwater contamination, city runoff, and urban drainage lead to water pollution and affect aquatic ecosystems. Pollutant dispersion. The spread of pollutants in the environment. Pollutant distribution. Pollutant spread. Pollutant diffusion. Pollutant scattering. What factors influence the dispersion of pollutants in the air? Pollutant dispersion, or distribution, depends on wind patterns. Pollutant spread, diffusion, and scattering are influenced by weather conditions, topography, and emission sources. Acid rain. Rainfall made acidic by atmospheric pollution. Acidic precipitation. Acid deposition. Acidic rain. Acidic fallout. How does acid rain affect ecosystems? Acid rain, or acidic precipitation, harms soil and water bodies. Acid deposition damages forests, acidic rain affects aquatic life, and acidic fallout disrupts ecological balance. Brownfield. Previously developed land that may be contaminated. Contaminated land. Polluted site. Industrial site. Redevelopment site. What challenges are associated with developing brownfield sites? Brownfields, or contaminated lands, pose significant challenges. Polluted sites require remediation, industrial site cleanup is costly, and redevelopment sites need thorough environmental assessments. Leachate. Liquid that drains or leaches from a landfill. Wastewater. Contaminated liquid. Polluted runoff. Toxic liquid. What are the environmental impacts of leachate from landfills? Leachate, or wastewater, contaminates groundwater. Contaminated liquid from landfills, polluted runoff, and toxic liquid pose serious risks to water quality in ecosystems. Pesticides. Substances used for destroying insects or other organisms harmful to plants or animals. Agrochemicals. Insecticides. Herbicides. Chemical pesticides. What are the environmental impacts of pesticide use? Pesticides, or agrochemicals, can harm non-target species. Insecticides and herbicides affect biodiversity, and chemical pesticides contribute to soil and water pollution. Herbicides. Substances used to destroy unwanted vegetation. Weed killers. Weed control agents. Chemical herbicides. Plant killers. How do herbicides affect agricultural practices? Herbicides, or weed killers, improve crop yields. Weed control agents and chemical herbicides reduce competition for resources, but plant killers can also lead to soil and water contamination if misused. Endocrine disruptors. Chemicals that can interfere with endocrine, hormonal, systems. Hormone disruptors. Endocrine disruptors. Hormonal disruptors. EDCs. What are the potential health effects of endocrine disruptors? Endocrine disruptors, or hormone disruptors, can lead to developmental issues. Endocrine disruptors and hormonal disruptors, EDCs, are linked to reproductive problems and increased cancer risk. Microplastics. Tiny plastic particles less than 5 millimeters in diameter. Plastic fragments. Plastic particles. Plastic microbads. Plastic debris. How do microplastics impact marine ecosystems? Microplastics, or plastic fragments, are ingested by marine life. Plastic particles and microbads accumulate in the food chain, while plastic debris contributes to widespread ocean pollution. Persistent organic pollutants, POPs. Chemical substances that persist in the environment, bioaccumulate through the food web, and pose a risk of causing adverse effects to human health and the environment. Organic pollutants. Long-lasting chemicals. Bioaccumulative toxins. Persistent contaminants. How do persistent organic pollutants, POPs, affect human health and the environment? POPs, or organic pollutants, remain in the environment for long periods. Long-lasting chemicals and bioaccumulative toxins build up in food chains, while persistent contaminants pose serious health and ecological risks. Eutrophication. Excessive richness of nutrients in a body of water, often caused by runoff from the land, leading to a dense growth of plant life and death of animal life from lack of oxygen. Nutrient pollution. Algal bloom. Water enrichment. Overfertilization. What are the consequences of eutrophication in aquatic systems? Eutrophication, or nutrient pollution, leads to algal blooms. Water enrichment causes oxygen depletion, and overfertilization from runoff results in the death of aquatic organisms. Bioaccumulation. The accumulation of substances, such as pesticides, in an organism. Biological accumulation. Toxic accumulation. Contaminant buildup. Chemical accumulation. What are the risks of bioaccumulation in the food chain? Bioaccumulation, or biological accumulation, leads to increased toxin levels. Toxic accumulation in predators, contaminant buildup in organisms, and chemical accumulation can have harmful health effects. Photochemical smog. Air pollution produced by the reaction of sunlight with pollutants such as hydrocarbons and nitrogen oxides. Smog. Air pollution. Chemical haze. Pollutant fog. What are the effects of photochemical smog on urban populations? Photochemical smog, or smog, significantly impacts health. Air pollution causes respiratory issues, chemical haze reduces visibility, and pollutant fog leads to long-term health complications. Thermal pollution. Harmful release of heated liquid into a body of water. Heat pollution. Temperature pollution. Thermal contamination. Heat waste. How does thermal pollution affect aquatic ecosystems? Thermal pollution, or heat pollution, disrupts marine life. Temperature pollution changes water chemistry, thermal contamination affects habitats, and heat waste leads to reduced oxygen levels. Hazardous material, HAZMAT. Substances that pose a risk to health, property, or the environment. Dangerous material. Hazardous substance. Hazardous chemical. Risky material. What safety measures are essential when handling hazardous materials? Hazardous materials, or dangerous materials, require strict protocols. Handling hazardous substances and chemicals involves protective gear and careful storage, while risky materials need regulated disposal. Air Quality Index, AQI. A system used to measure and report air quality. Pollution Index. Air Pollution Index. Air Quality Measure. AQI Level. How can the Air Quality Index, AQI, help in managing pollution levels? The Air Quality Index, or Pollution Index, indicates pollution severity. The Air Pollution Index helps people take precautions, while the Air Quality Measure and AQI level guide regulatory actions to improve air quality. Noise pollution. Harmful or annoying levels of noise. Sound pollution. Acoustic pollution. Noise disturbance. Unwanted noise. What are the health effects of noise pollution in urban areas? Noise pollution, or sound pollution, can cause stress. Acoustic pollution and noise disturbance disrupt sleep, while unwanted noise impacts mental health and overall well-being. Desalination. The process of removing salt from seawater. Water purification. Salt removal. Water desalinization. Freshwater production. What are the benefits and challenges of desalination for providing fresh water? Desalination, or water purification, provides fresh water. Salt removal makes seawater drinkable. Desalinization processes are crucial in arid regions, and freshwater production supports growing populations. Recycling. The process of converting waste into reusable material. Reprocessing. Reuse. Material recovery. Waste reclamation. How does recycling benefit the environment? Recycling, or reprocessing, reduces waste. Reuse of materials conserves resources, material recovery minimizes landfill use, and waste reclamation supports sustainable practices. Composting. The process of turning organic waste into nutrient-rich soil. Organic recycling. Biodegradation. Soil enrichment. Organic waste recycling. What are the advantages of composting organic waste? Composting, or organic recycling, enhances soil quality. Biodegradation of waste produces nutrient-rich compost, soil enrichment supports plant growth, and organic waste recycling reduces landfill waste. Environmental Impact Assessment, EIA. The evaluation of the environmental effects of a proposed project. Environmental Review. Ecological Assessment. Environmental Analysis. Impact Study. Why is an environmental impact assessment, EIA, important for new projects? An EIA, or environmental review, identifies potential impacts. Ecological assessments and environmental analyses guide mitigation measures, while impact studies ensure sustainable development practices. Cap and trade. A system for controlling carbon emissions by providing economic incentives. Emission trading. Carbon trading. Carbon market. Emission cap. How does the cap and trade system help reduce greenhouse gases? Cap and trade, or emission trading, limits emissions. Carbon trading incentivizes reductions, the carbon market sets prices, and emission caps enforce compliance, all working to lower greenhouse gases. Life Cycle Assessment, LCA. The assessment of environmental impacts associated with all the stages of a product's life. Life cycle analysis. Environmental assessment. Life cycle evaluation. Product life analysis. What is the purpose of a life cycle assessment, LCA? An LCA, or life cycle analysis, evaluates a product's environmental impact. Environmental assessments, life cycle evaluations, and product life analyses inform sustainable design and production practices. Organic farming. Agricultural practices that do not use synthetic fertilizers or pesticides. Sustainable farming. Eco-friendly farming. Natural farming. Green farming. What are the benefits of organic farming? Organic farming, or sustainable farming, promotes biodiversity. Eco-friendly farming avoids chemicals, natural farming improves soil health, and green farming supports long-term agricultural sustainability. Energy efficiency. Using less energy to provide the same service. Energy conservation. Energy saving. Efficient energy use. Reduced energy consumption. How can improving energy efficiency benefit households and the environment? Energy efficiency, or energy conservation, lowers costs. Energy-saving practices reduce emissions, efficient energy use maximizes resources, and reduced energy consumption minimizes environmental impact. Carbon trading. Buying and selling of carbon emission allowances. Emission trading. Cap and trade. Carbon market. Carbon credits. How does carbon trading contribute to environmental sustainability? Carbon trading, or emission trading, controls emissions. The cap and trade system, carbon market dynamics, and trading carbon credits incentivize reductions, promoting environmental sustainability. Carbon sequestration. The process of capturing and storing atmospheric carbon dioxide. CO2 capture. Carbon storage. Carbon trapping. Carbon capture. What are the methods and benefits of carbon sequestration? Carbon sequestration, or CO2 capture, reduces atmospheric CO2. Carbon storage techniques, carbon trapping methods, and carbon capture technologies help mitigate climate change by storing carbon underground. Renewable energy. Energy from a source that is not depleted when used. Sustainable energy. Green energy. Clean energy. Alternative energy. What are the advantages of using renewable energy sources? Renewable energy, or sustainable energy, reduces emissions. Green energy sources, clean energy alternatives, and other alternative energy solutions decrease reliance on fossil fuels and mitigate climate change. Industrial emissions. Pollutants released into the atmosphere from industrial processes. Factory emissions. Industrial pollution. Industrial discharges. Plant emissions. How can industrial emissions be controlled to reduce pollution? Industrial emissions, or factory emissions, need strict regulation. Reducing industrial pollution and controlling industrial discharges, along with minimizing plant emissions, are essential for cleaner air. Landfill leachate. Liquid that drains from a landfill and contaminates groundwater. Leachate runoff. Leachate discharge. Landfill runoff. Contaminated leachate. What are the environmental impacts of landfill leachate? Landfill leachate, or leachate runoff, pollutes groundwater. Leachate discharge and landfill runoff contain contaminants, while contaminated leachate requires treatment to prevent environmental harm. Bioreactor. A device that supports a biologically active environment. Biological reactor. Bioprocessor. Biochamber. Microbial reactor. What are the applications of bioreactors in environmental management? Bioreactors, or biological reactors, support waste treatment. Bioprocessors enhance biodegradation, biochambers treat wastewater, and microbial reactors manage contaminants effectively in environmental management. Environmental contamination. The presence of hazardous substances in the environment. Environmental pollution. Environmental tainting. Ecological contamination. Habitat contamination. How can we address environmental contamination in urban areas? Environmental contamination, or pollution, requires cleanup. Addressing environmental tainting and ecological contamination involves remediation, while habitat contamination demands preventive measures. Waterborne diseases. Diseases that are transmitted through contaminated water. Water-related diseases. Waterborne infections. Aquatic diseases. Water-transmitted diseases. What measures can prevent waterborne diseases in developing countries? Preventing waterborne diseases, or water-related diseases, involves improving sanitation. Reducing waterborne infections, addressing aquatic diseases, and controlling water-transmitted diseases are crucial steps. Climate mitigation. Efforts to reduce or prevent the emission of greenhouse gases. Climate action. Emission reduction. Climate control. Climate management. What are some effective strategies for climate mitigation? Climate mitigation, or climate action, involves various strategies. Emission reduction techniques, climate control measures, and climate management practices help combat global warming and environmental impact. Emission factor. A coefficient that quantifies the emissions from a specific source activity. Emission rate. Emission coefficient. Pollutant factor. Emission index. How do emission factors help in controlling air pollution? Emission factors, or emission rates, are critical for air quality management. These coefficients, or emission coefficients, allow accurate pollutant factor analysis and enable better control of emission indices. Geothermal energy. Heat derived from the Earth's internal heat sources. Earth heat. Thermal energy. Geothermal power. Subsurface heat. What are the advantages of using geothermal energy? Geothermal energy, or earth heat, is a sustainable resource. Utilizing thermal energy from geothermal power provides consistent and eco-friendly subsurface heat for electricity generation and heating. Hazardous air pollutants, HAPs. Airborne substances that pose significant health risks when inhaled. Toxic air pollutants. Dangerous air chemicals. Harmful airborne substances. Air toxins. What measures can reduce the risk of hazardous air pollutants, HAPs? Reducing HAPs, or toxic air pollutants, involves stricter regulations. Controlling dangerous air chemicals, monitoring harmful airborne substances, and minimizing air toxins are essential for public health safety. Non-point source pollution. Pollution from diffuse sources that is not from a single point of origin. Diffuse pollution. Indirect pollution. Runoff pollution. Nonspecific pollution. How does non-point source pollution impact water quality? Non-point source pollution, or diffuse pollution, contaminates water bodies. Indirect pollution from agricultural runoff, along with runoff pollution and nonspecific pollution, leads to significant water quality degradation. Particulate pollution. Pollution caused by tiny particles suspended in the air. Particle pollution. Particulate matter. Airborne particles. Particle contaminants. What are the health effects of particulate pollution? Particulate pollution, or particle pollution, impacts respiratory health. Particulate matter, such as airborne particles and particle contaminants, can exacerbate conditions like asthma and cardiovascular diseases. Photovoltaic systems. Technology that converts sunlight directly into electricity. Solar panels. PV systems. Solar power systems. Solar cells. What are the benefits of photovoltaic systems in renewable energy generation? Photovoltaic systems, or solar panels, harness renewable energy. PV systems, solar power systems, and solar cells provide sustainable and efficient electricity generation from sunlight. Resource recovery. Extraction of useful materials or energy from waste. Material recovery. Waste reclamation. Resource extraction. Resource recycling. How does resource recovery contribute to sustainable waste management? Resource recovery, or material recovery, reduces landfill waste. Waste reclamation and resource extraction ensure valuable materials are reused, while resource recycling supports environmental sustainability. Smog-forming emissions. Emissions that contribute to the formation of smog. Smog precursors. Smog pollutants. Smog-causing emissions. Smog-inducing emissions. What are the sources of smog-forming emissions, and how can they be controlled? Smog-forming emissions, or smog precursors, come from vehicle exhausts. Controlling smog pollutants and smog-causing emissions through regulations and reducing smog-inducing emissions improve air quality. Toxic emissions. Harmful chemicals released into the air from various sources. Hazardous emissions. Poisonous emissions. Dangerous emissions. Toxic pollutants. What are the strategies to reduce toxic emissions from industrial activities? Reducing toxic emissions, or hazardous emissions, involves stricter controls. Mitigating poisonous emissions and managing dangerous emissions and toxic pollutants through cleaner technologies and regulations are vital. Wind energy. Energy obtained from the movement of the wind. Wind power. Wind-generated energy. Wind electricity. Eolic energy. What are the advantages of wind energy as a renewable energy source? Wind energy, or wind power, is a clean and sustainable source. Wind-generated energy and wind electricity from turbines, along with eolic energy, significantly reduce reliance on fossil fuels and lower emissions.